start this. Okay, your SGSN is basically responsible for selecting GGSN that is based on your APN. So, and in different operator, the configuration is different. Maybe you have specified that, okay, this APN1 will be served by GGSN1 and maybe APN2 is served by GGSN2. So the selection of GGSN from SGSN is based on the APN, and specifically each entry is remembered or recognized by the host name index, and then each of the APN will have a specific host section address. It can be section 0, section 1, section 2, and accordingly it will have the IP address of the GGSN specified in it. So we're going to look into it a little bit deeply in the upcoming slides. Just what I can do is that I can I can open it over here. Right. So, okay. So, starting with the local entity configuration, the service IP will be configured, which is basically going to be the source IP address for the GNGP communication of the SGSN. So it's going to be done by service IP like we did for all other nodes as well. And then you have the GTPC and the GTPU IP address, the source IP address, which would be used in GTPC communication and in GTP information. So the command is add GTPC a local entity, and then you have a group ID, and then you specify which type of IP address is it, and the local entity IP specified, and the VPN. So this VPN, because all your communication are based on different DRF instances or different VPN instances, so you have to specify that it's which VPN. Because if the IPs belong to different VPN instances, then they won't be able to communicate with each other. So this has to be ensured that the VPN instance set is correct. Same goes for GTPU IP address. So it's either it can be the same IP address or it can be a different IP address. That depends on how you plan your network. Okay, next are some parameters related to your path management. These are configurable based on what your network requires, and usually default parameters are configured here. Yes, specifically you can specify which GTP version is here, so that will be depending on which version you are going to use. Other than that, most of the threshold values or the signaling values are those that are usually default values, or if specifically something is required, it is. Okay. Now we come towards how your IP address of the GGSN is selected based on your APN. So most of you would be knowing that it's done via IPv4 index, your DNS host file. So DNS host file is configured using the command add IPv4 DNS, and HAC index is once again this index ID represent whole of this entry. So here what you're mentioning is that this APN will be resolved into this IP address. These are the two IP addresses, and address section can be different. You can specify address section 0, section 1, section 2. This is usually required. If you look into this command deeply, you have the option of setting a priority, and you have the option of setting a wait as well. So what I can do is that if I have two IP addresses, I have two different GGSN. One GGSN has this IP, and the other one has this IP. So what I can do is that I can add HAC index 3, and then I will specify this same APN will have two sections. Section 0 with this IP address, priority will be 1, and then section 1 with this same APN will have this IP address 2, and its priority is going to be 2. So ideally, over the priority, higher is its selection compatibility. So whenever the SGSN gets this APN address, it is going to resolve it into IP address that has the lowest priority index configured. So the IP that will be configured in section 1 is going to be selected. Yes. In case your this IP is not accessible or you remove this entry, then you can use this section 1 entry to resolve it into this second GGSN IP addresses. So This is the concept of section, that you can have multiple IPs against a simple APN, against a single APN, and those can be different commands can be differentiated based on their section IDs. Okay, so your hostname index 3, and then you have your hostname index 4. Hostname index 4 is for a different APN. I mean, if the APN is going to be the same, you cannot change the hostname index. Okay, so hostname index is going to be the same. Is going to be different if your APN is different. So you can see that its MNC is different. Here it's 0, here it's 1, and accordingly, the APN of the GGSN can be same or it can be different. And then specifically on SGSN, you need to add the GGSN characteristics as well. So this is a pretty simple command where basically you are identifying the IP address of the GGSN in the GGSN characteristic command. And then if there is any specific characteristic that you need to add, you can add it in this. But plainly, what you are adding is the IP address, and this quality of service version is the default quality of service version. Okay, next is the interworking between different SGSNs. Now we look how SGSN correspond with GGSN. Now, if one SGSN is communicating with the other SGSN, and this we looked into it when we were looking into inter-MME routing area update. So when there is an inter-SGSN routing area update, if one SGSN was hosting one user and then the user goes to another location and there is another SGSN, so how the communication between the two SGSNs take place? How they, based on your routing area ID, how does your SGSN recognizes that, okay, which is the old SGSN which will have the context of this user? Okay, so here the process of attach, you can have it in attach and routing area update in SRNS transition. The two SGSN need to communicate with each other, and this is based on the old routing area. The old routing area ID basically corresponds to the SGSN IP address, so this needs to be configured against the new SGSN IP address. And the IP address solution is completed based on the host file or the DNS. So host, usually it is done based on your host file, the IP for DNS index. Other than that, you can also add his entries in the DNS as well. Okay, so the first thing is configuring a static route. So this is an optional. If you need to ensure that a static route is there between the two SGSN, so you can add it using add SS route. And the other one is basically the interworking between SGSNs. So this we're going to check. So this is an example that this is one SGSN which is having a GTPC IP address and the GPU IP addresses and its interface IP address. Okay, and then there is a router that is connecting the two SGSN, and then the other SGSN has a different IP address. So the command here is going to be add static route. You have specified the VRF name. This needs to be the same. The direct VPN instance. Okay, and then you specify the prefix. The prefix is going to be, since there are two IP addresses, so it's specifying that this is the prefix, or otherwise you can add different static route IP commands for two different IP. But since the prefix from 211.0 onwards is 211.0 is the common prefix, so we can use the prefix option. And then the masking length is going to be 16 to specify that, okay, all the IPs corresponding with 0 onwards are going to be routed, have this static routed towards this IP address. Okay, and then the next hop IP address is this. The next hop address is going to be the gateway IP address. Okay, and then you have to specify the interface name as well. So this is your interface that is basically on the SGSN that is going to be communicating with the router address. Okay, but this is something that is optional. Usually this is not configured. Yes, the other one is adding an entry, an SGSN entry in the IPv4 DNS. So this is one example. The command is add IP for DNS index. This host index is unique, and in the host name you specify the RNC or the routing. Here I have specified the RNC. Okay, so if communication, if you need to communicate with, if your request is coming from one RNC, and then your user changes its RNC, its routing area ID, and in SRNS relocation, this thing, the SRNS relocation or transition is done when one RNC is communicating with the other RNCs. So This has been taken as an example. So if the incoming request is from an RNC, old RNC, so how to identify that this RNC was hosted on SGSN? So the RNC host name will be resolved into this IP address of the SGSN. Okay, so your old RNC belongs to this IP address, and once you initiate an SRNS relocation or SRNS transition command, your communication is originated from the new RNC towards the new SGSN. So its old RNC and its old SGSN IP address is resolved from this IPv4 DNS host name index. Okay. And here you can see for each of these address, for each of these IP addresses, we have a specific priority and we have a specific weight. So for example, I mean, in case of SGSN identification, usually multiple IP addresses are not used, but in case your APN is being resolved into multiple GGSN IP addresses, in that case, you can add this secondary IP address here as well. And then you can specify that, okay, it has a lower priority, or if you need to load share your traffic between multiple GGSNs, again, you can set the priority to be the same, and then you can specify a weight. For example, 20% will be here and 80% is going to be here, and so on and so forth. Okay. So, I mean, and in case you need to specify some routing area, I mean, if you're getting a routing area update, so in that case, the host name is going to be replaced by your routing area ID. So you'll have your RAI, and then the RAI ID, then you're going to have a LAC ID, and then you're going to have the MCC and the MNC and the GPRS. So based on your old routing area ID, you can identify that which SGSN was hosting the context of this user, and then you can communicate with this IP address in order to get the context of the MSID and NSMG and all that information for routing area update, or in case it's an attached under a new SGSN as well. Right. So once this configuration is done, so you can check this using ping.
Sir,
yes.
One query: if we want to configure 50% traffic at this SGSN, then the weight will be 50.
You're talking about for GGSN, right?
Yes, sorry, yes, GGSN.
So
About
like
weight configuration.
Okay, so let's do it here. Okay, let me just add this command over here, and because the syntax is already mentioned here, so what we can do is, okay, let's just specify this to be till here. Okay. So okay, so what you want to do is that you want to specify that, okay,
There are two.
Okay, there are two GGSNs.
Yes,
okay,
yes.
so let's just modify this a little bit. Okay, and let's say this is what we have. Okay.
Yes.
Okay. So this is your APN. This is your address section. This is the IP address of your first EGSN. Okay. And the priority is this. So here, what you're going to do is you're going to change the priority weight to 50, and then this is the IP address of the second EGSN. And here again, you're going to change its weight to 50. So whenever any user wants to create a PTP context with this APN, 50% of your users will be assigned this IP address to create a context, and 50% are going to be assigned this IP address. Okay, and you can even modify it. For example, this GGSN has a higher capacity, so you can keep it to 60, and you can keep this to 40%. Okay, but like this. Okay, so it's all based on the capacities of your GGSN. If your GGSN has equal capacity, you can configure equal weight. If you want to specify that, okay, no, from this SGSN, the routing request should always go to one GGSN. So for that, what you can do is you can add another, because this is something I'm mentioning with respect to your redundancy as well. For example, one GGSN goes down. So instead of creating a script at that time and executing a script, what you can do is that you can, here you mention this. This is going to be your address section 2. Okay. And what you can do is that you can set its priority to 2. For example, I'm going to set its priority to 1. Okay, its weight I can specify it to be, okay, let's add another command. So this is, so this above command is basically for your distribution, your weight distribution, and then these 2 commands are going to be if you want to configure redundancy as well. Okay, so what we can do is this address section 1, and you specify this priority is 1, it's weighted 100. Okay, let's say it's 100. Weight 1 is 100, and we don't need any secondary IP address. Okay, so this is one command, and the
Same
second
thing.
one, the IP is going to be this. Its priority is going to be lower. Its weight is going to be same. Okay, and then we don't need it. So now
Yes,
what's
yes.
going to happen is that always your traffic, your whenever this APN comes into play, it is always going to be resolved into this IP address. However, if you think that you need to have a secondary GGSN as well. So what you can do is that if this GGSN goes down, you can simply remove this. Either you can remove this or you can change the priority of this. For example, you can change the priority and set it to 3. In that case, all your traffic will start going to this IP address, the GGSN bearing this IP address, and it won't be going into this one. So it's always a good practice to have these configurations on your system and just modify the priority of this in order to ensure that, okay, you can remove this. Either you can remove this entry or you can change the priority in order to ensure that your traffic gets routed towards this IP address instead of this IP address. And in case you need to do port sharing, you can always do it like this. Okay, and if so it's all up to you. Okay,
Thank you very much, sir.
yeah.
Very clear. Thank you. Thank you.
Okay, so okay, so the commissioning method, the first one is to check the ping results. The other one is to test your GTPC path and the GTPU path. Okay, so GTPC path is going to be, the command is going to be like this. You specify which version, this is the version that is configured, and then you specify your local address, the SGSN address, and the GGSN address, or it's the other SGSN address. So you can execute this command and you can check if the result is successful or not. This will ensure that your routing is being successfully done. Okay, this is an optional route function. Another feature that is available in your SGSN is that you can route a specific APN. I mean, a specific APN can be routed. You can route a specific IMSI or a specific IMSI range to a specified GGSN as well. For example, you need to perform a testing from a GGSN that is located in another region. However, your SGSN is diverting all your traffic to to your local GGSN as well. So you have an option of routing your specific IMSI to a different GGSN based on that specific APN. Okay. So GGSN selection based on IMSI segment. In the activation process, SGSN can query whether the IP address correspondence is configured based on the subscriber IMSI. So you have an option of specifying that, okay, my IMSI, if a create PDP request comes from my IMSI, then it should be routed to a one specified GGSN that is configured in a command. If yes, this IP address can be directly without starting the DNS resolution process. If no, the GGSN can use the OI to construct an APN and find the corresponding GGSN IP address using DNS resolution process. And the IP address GGSN does not exist, the default APN can be used to query the corresponding GGSN IP. This is the case where the IPN, that APN against your number is not configured, or it's not provided by HSS. Okay, so specifically the command is this one, the add gateway selection policy. Okay, and for example, I'm going to make this a little bit clear. You have this GGSN, these two GGSN. Okay, so this is your routine configuration in which you are specifying that all your traffic should go towards this APN, toward this specific IP address. Okay, now I think I can add a pointer here as well, which will maybe give a better. Okay, so your default configuration states that all this APN is going to be resolved into this IP address. So this is one GGSN that is going to be handling all traffic. Your requirement is that, okay, my IMSI is this, and I want my IMSI to be served not from this GGSN, but from a different GGSN, which is bearing this IP address. So using this command, gateway selection policy, you can specify your IMSI. In case it is just for a single IMSI, you're going to select the subscriber ranges IMSI range, and begin IMSI and end IMSI is going to be the same. In case you need to route traffic for one 10,000 MZs. So starting from 60000 till 69999. So all those MZs which lie in between this range are and they are bearing any APN. I mean, if the APN NI is selected as static, it means any APN. If you need to route a specific APN, then you can specify the okay one APN 1 or APN 2 or APN 3. So all the create PDP requests of these IMSIs are going to be routed towards this GGSN, and this GGSN is going to provide the data services for these IMSIs. The rest of the IMSIs, those IMSIs which start from, for example, 57700 till onwards, or from 00 till 5999, all of these are going to be served by this GGSN. Okay, this is specifically used when you need to route a single IMSI or a test IMSI towards a GGSN. In that case, what you can do is that you can specify this IMSI to be the begin IMSI, and you can specify this to be the end IMSI as well. In that case, only a single IMSI is going to be routed towards okay here. So the begin IMSI and the end IMSI is going to be the same, which means that a single IMSI bearing any APN will be routed to this GGSN, and all the rest of the IMSIs except this one are going to be routed towards this GGSN IP address. Okay, and if you need to route your IMSI, a specific IMSI with a specific APN, in that case you need to mention the APN here. Okay, so you specify the APN here as well. I mean, the command can be something somewhat like this. Okay, so this IMSI which is bearing this specific APN will be routed to this, and this IMSI that has another APN, any other APN apart from this APN, will again be routed to this. And this command is for adding a specific operator index to it. I mean, if you have some specific requirement where you need to replace the operator ID against your this APNs, so you can do it for that specific IMSI. Your operator ID, the operator ID this for the MNC and GPRS, that can be replaced for this network identifier of the APN part. Okay, so this command can be used for this operator index configuration as well, but usually 99% of the time what I've seen is that it is this gateway selection policy is usually used for routing a specific IMSI towards a specific GGSN address for testing purpose or for some other one as well. Okay, can we select MME also? Like if we yeah, sir, MME configuration will come afterwards. We are currently covering the SGSN configuration. We will move to the MME, then we'll discuss it over there as well. And yes, we can do it. We can select another like if you want to subscriber specific, okay, specific SGSN or specific MME you want to do, this is not controlled from MME. This is controlled from your eNode B, or for this perspective, is controlled from RNC end. So it is the responsibility of RNC, or RNC has the weight configured or the routing or priority configured to route one specific number. And I don't think the RNC has an option of doing it IMSI wise. It usually does based on whole of the IMSI segment. Someone from RAN can better comment on this, but I don't think that we have an option of routing one user from RNC towards one specific SGSN. In case of 4G, yes, we have an option available, and that we will discuss once we come to the MME configuration. We have an option available when we have MME pool. So we can route our number from one MME to another MME if both the MMEs are in a pool. Okay, the SGSN can also select a DNS server that is based on your APN OI. If the mapping relationship between APN OI and DNS server is configured on the SGSN, the DNS can select directly for the resolution. This is the case in which you don't have the IPv4. If the entry is not found in your the IPv4 hostname index, in that case, you can do similar configuration in DNS as well, and we will cover it when we discuss the DNS configurations as well. Give me a minute. Okay, so configuration of DNS, I think it's included here, so we can add it here as well. Okay, this is the configuration if you need to configure your internal DNS as well. Okay, this is talking about the GN DNS. One is the GI DNS. GI DNS is your external DNS, and GN DNS is the DNS that is used for resolving your APN, or specifically it is used for resolving whenever you have an international roamer that is inbound roaming, so its request is always going to go to a DNS server. You can't have the configuration for all the APNs and all the operators in your local IPv4 DNS. Okay, so configure a DNS server. You add a DNS server. You specify a group ID and you specify an IP address in this. In one group ID, you can have multiple IPs, and they can have a different priority as well. And then you can play with this priority as well. Like you can assign one IP address a higher priority and the other IP address a different priority as well. Okay. Configure the mapping between the APN OI and DNS server, DNS queue, subrange this. So in this group ID, any APN that is going for resolution in the DNS, it is going to be okay. Any APN that does not have an operator index, that is going to be wait, just give me a minute. Just give me a minute. Okay, so if you have an APN that is just a network identifier part, for example, your APN that is coming is this Huawei.com. Usually the APN that is configured in your handset is usually this part. You don't configure the whole APN like MNC and MCC. Okay, so once you are going to resolve your APN from DNS, you need to specify the operator index as well, because your root DNS always recognizes this part. It always takes up this part and then it adds and resolve it. It recognizes an operator based on this part. So I mean, configuring an APN operator index for this specific group ID. This is a command to add your operator ID. Okay, for any resolution of your DNSs. Okay, next is your GA interface. Okay, your GA interface, if you remember, is the interface that is used between your charging gateway and your SGSN and the GGSNs. Okay, this diagram gives a bit of simple explanation of this. So SGSN and GGSN are communicating with GNGP interface, and then from with charging gateway communicating with the CDRs is going to be on the GA interface and then the GI interface. Okay, so there are different types of CDRs. One is your mobility CDRs, one is your SGSN CDRs, and then there are some SMS related and location related CDRs. Usually, we are concerned with these two types of CDRs, SCDRs and MCDRs, or usually in most of the crime it is SCDRs. So we're going to just check how your CDRs are encrypted. Start and stop SCDRs. When your PDP is successfully activated, the SGSN starts an SCDR, and when your PDP is terminated, your SCDR is closed. So CDR is opened when PDP is activated, and it is closed when your session is terminated. Okay, and then there is an option of partial CDR condition, because I mean, if you activate a PDP and you keep your PDP open for 2 hours or 3 hours, the size of the CDR or the content that is contained in the CDR is going to be huge. So what the option we have is that we can generate partial CDRs as well. In this case, your charging ID remains the same. So I mean, if for one session you can have 3, 4, or even 10 or even 15 CDRs as well, and they all will be considered as partial CDRs. And the common thing in those CDRs is going to be your charging ID. When you create a PDP request and your request comes from GGSN, it also has a charging ID as well. So based on a charging ID, all of your partial CDRs can be recognized. Okay, so some okay, one more. If we have an APN internet for normal use and this is configured on then how specific PGW will be selected? Yeah, so this will be select. I mean, we have this in this case also. You have two options available. One is that you can do it using gateway selection, or you can do it based on one APN can be assigned a different IP address. Okay, guys, just give me a few minutes. I have an incoming call, okay, and then we will resume the training session in like 5 to 10 minutes, okay.